Alright, so I'm gonna start debugging this these Java questions. Alright, so the first one I'm actually gonna start with is the linked list, and then go to the clock problem, and then the tip calculator and Wonderland. That's if I happen to get through all those. So I'm gonna just do an hour right here. So start a timer. Alright, so this is based off, I already read through this, and I did not look at the problems yet. So all I did was I added it to the actual folder. And yeah, so first thing I want to do is actually get to that directory. So I actually do a bunch of my code in just a terminal, and then I do any of the debugging within the Eclipse, because there's a bunch of reasons why I use this, and Vim and all that, because it's like you get really good at the commands. But the first thing that I want to do is go into the bugs folder. Okay, so I want to start with the lists. Okay, so the first thing that, let's make sure that's recording though. Yeah, the first thing that I want to do is actually just look at the code before I even try to do anything. So first thing, alright, so we have a linked list right here. I always find it, I understand it better like this for some reason. Okay, so actually, I don't know where this ends at. Let me check. So this is a cool thing. Oh, so it's a full linked list. Okay. I mean, this is the whole thing. So we have a first, we have a last, and we have n, which is the number of items in the linked list. And so this holds a first link to least recently added node, link to most recently added node. Okay. And then we got an object item, node next. Okay. So I also want to open that other file. So I get the path. There we go. So I get the path of where I'm at right now, because in this directory, see the bottom little red thing? I'm in this directory. Say, okay, I want to get there. So I just cd and I just paste it. I'm in here now, list. Now let's look at simplify list. Okay. Simplify list. Oh, I see. So this is kind of like in C++, this would be like the header. Okay. Okay. So I'm actually gonna look at this right here. I'm actually gonna run it to see what it's even doing. So we have the list tester. Okay, we got a couple things here. Does it run? Oh my god. Okay, so that works. We want to do a test set. What's that? Test set did not return the correct prior value. So we're testing the set method, right? The set method right here. So what does the set method do? It checks if the provided object is in the list. So first it has to check if the actual object is in the list. And then the object to search for the parameters is the object to search for, and return true if the object is within the list. I think the provided object is in the list. Oh, I'm reading the wrong one. Alright, so I was wondering why it wasn't making sense. Alright, set the provided object to the provided position in the list. So go to that index. An index should be less than size. Yeah, so that's just saying you don't want the index. So if the size of the array, the linked list, was 10, you don't want to put an index that's like 30 because there's no such thing as that. Pass element. Then we want the actual elements, the object to save, and then return the object that was previously at that location, or null if the index is greater than the size. Okay, so that makes sense. So the issue is set did not return the correct prior value, expected B but was E. Okay, so what's going on here? We are making a new linked list and then fill list with a bunch of test values. Okay, and then we're saying here that each value reverse value, so we're getting a reverse value. Okay, so actually it doesn't matter what that reverse value does, because that should work, I believe. The issue is now that the set is not working. So let's look at the set. So we have set right here. Okay, and usually what I like to do, I don't know if anyone else does this, but I add like 20 lines below and like 20 lines above. That way I just look at this, because I sometimes just looking at a bunch of code next to each other that are completely irrelevant or like don't even need to worry about, it's just kind of like in the way. So usually I like to do this and separate it. I just want to make sure that everything's working okay, because I don't want to record and then all of a sudden all that was for nothing. So then I just move some things around just because that's how I like to set it up. Like for example, this if, I don't really need that, so I can take that out. And so I like to space it out a bit, get some space so I know what I'm looking at. So okay, if index, why? Okay, if it's a negative number, or if n, what is n? What is n? Where's n even coming from? Okay, so n is the size, or let's call that size. Oh, n's right here. Number of items, okay. Assuming the size does work. We're saying if it's a negative number, or if the index is greater than the size. So say the size was 5. And this is the weird part, because we're going to be working with indices, and n will be the actual size. So say if n equals 5, then that means, or n, which is a size, equals 5. And that means that index should go up, it will be from 0 to 4, which is also 5. This would be 1 through 5. So that means, so yeah, the size would be 5 objects, but in terms of index position, it'll only go from 0 to 4. 0, 1, 2, 3, 4, yeah. So, is this correct? So say if n, and this is index. So, that's the max. Okay. So if n equals 5, okay, we have 5, and it's saying if the index is greater or equal, yeah, that makes sense, because that's saying, hey, if n equals 5 and if the index is 4, that's fine. But if the index is 5, then you're out of that range, so it should return null. So this is fine. Next we call the get. So previous node item. So previous node item, get index. Okay. So let's go to get index. Okay, so the cool thing is I can just do this. Oops, where am I? So I might get, and let's see, this makes sense. Let's see, this makes sense. So we already verified that makes sense from the last one. Okay, we set I to 0. And node x equals first, okay. X, as long as x is not equal to null, then we go to the next one. Okay, that makes sense. And now we're saying that each node that we get, if I happens to be equal to the index, return x dot item. X dot item. Okay, so I was wondering what the object. So the object is the item. Okay, so we were here. Okay. So, okay, that makes sense. So if I is equal to the index, then we return the item. Then we increment, or say if it doesn't, then we increment back and keep going. So that seems like it works. Okay. So that's fine. That's fine. And then now we're doing the same thing here. We're doing for node x, yeah, okay, we get that. So we're saying, hey, if we find the index, we want to set x dot item equal to element. Yeah, that looks like it makes sense to me. So we set the element. What do I put a break, because we don't really need to. I always okay, whatever. So we find the index, we set it, and then we break. So we're done with that. Oh, what the heck? Well, that's probably why. This is outside of the loop. It should be in here. Yeah, it should be in there because it was outside, and if it's outside, that means it's always gonna check 0, and that's it. That doesn't make sense. It's because I don't have it set correctly. Let me make sure. Okay, got that. Now, ideally, that should work. Okay. Yeah. Okay, so that worked. That's all it was for that. Then we want to do test clear. What is the issue here? Empty list did not return a size of 0, but was 5. So something about the clear is not working. And we just go here, we jump to where that is, test clear. Looks fairly simple. We make a linked list, we fill the list, then we call it clear, but it's not clearing. So, well, we can also check here too. I want to see what the definition, clear the list. Okay, clear the list values. Okay, wait. Oh my god, that's funny. That's funny because it's just doing this. It just completely ignored all the other values inside. That's pretty funny. That's a funny bug. So, yeah, because you're just setting like the head and the tail as null, but all the other values are still there. Object is set. Okay. So I guess the first thing would actually have to be going through the whole linked list. Well, that is correct though, but we're just missing we're not doing the other, we're not erasing other values. Okay, so what we want to do is actually increment. So node x equals first. Okay, we would say this for last. Paste that there, delete that. Yeah, we don't return null. And then we don't really care about this. We don't really care about incrementing. We just want to x the item. We want to set that to null. I believe that deletes it. I don't know if there's a delete key. It kind of carries now. Okay, so I guess deleting a node would just be setting it to null. Seems like. Because of garbage collection? So I've been so used to C++. I've been so used to C++ that I just delete because there's no garbage collection. I think that's the right term for it. So we just set it to null. Okay, right? Okay, so we can just do equals null, item equals null. So it should just be X. Okay. X item. So I can do something like this, mark target. So what did I just do? You didn't see it, nothing popped up. But if I were to, like, you know, get confused, or I was like, wow, I don't know where I'm gonna go back, I just do this. Boop, and I'm back. And the reason why I do that, so I can look at the top. I want to see what it is that I'm actually. This is an object, private class node. I think we can leave node alone, not have to worry about that. I think we just have to do that. So. So, I think this should be fine. And so the issue is, it's not clear, test, empty. Maybe that's it, let's see. No. Oh, I guess we have to also do minus. Okay, yeah, huh. That's what it was. So that's that one. That way. That way. Back that way. Yeah, that should be good. Okay, so we figured that one out. Next is test remove. So let's check remove. I just want to read what it says. The object search for true if the object was in the list and removed. Okay. So we don't have anything here at all. So we need to. So there's some other methods here that are not used, like these. I guess these are like helper functions. So test that remove, it probably calls these, but just let's see. We remove the size. Move. Okay, it doesn't. So how will we remove an object? So we need to do kind of something similar to, let's mark this one. I'm gonna mark this one. So I'm gonna go back to where my iteration thing was. I think you can just like that, and I can go back here. Wherever that was, okay, paste that. Okay. So remove object O. So we need to if I think it was like O dot equals X dot item. We get X dot item to equal to the object. Something like that. Okay. Hide that stuff. Let me fix this real quick. Okay, what's going on here? So we're saying get the node, try to find the node, and or at every node, at every iteration, if the object we're looking for is at the current iteration, we want to remove it. So we set to null, right? So we removed it, but I don't know if this is a doubly linked list or a single linked list. I don't remember. So let's check the top. So there's only next. So there's only next. There's no previous. So that's gonna be a little weird, tricky. So we can't delete it. We need to know. We need to check the next item. So you can say just think about this for a second. We can't necessarily I think in this iteration, we need to check the next one. Make sure that's not equal to null pointer. Why do we want to do that? Because if you can check the next one, and make sure it's not equal to null pointer, then we can go to the next one, compare that item. Because we want to know what the previous node was. That way we can send that previous node next to point to the next node. So I gotta rework this. So paste that. So we want to switch this up a bit. We want to say node x equals first. That's the starting point. Well, x, so it should be x dot next is not equal to null pointer. Go to the next one. And now we can do if O dot equals, so that's right, equals x dot next dot item, then we can set x dot next dot item equal to null, and then we can set x dot next equal to we can set x dot next x dot next dot next, and then we subtract there. return true. And it's saying yeah, so we can, if it doesn't find it, okay. So what do we have so far? So we're saying we want to get the next iteration. You want to make sure, so we're right here, maybe reversed. We're right here and we want to get the next one. Yeah, okay. So we're right here, we want to get, we're right here, but we want to get the next one. Or we want to know if the next one is not null. We don't necessarily care about, we're not checking the first one if it's null. And we don't do that because we want to know what the next, we want to make sure that the next one's not null in order to compare the next item. And also so we can have the previous item point to the next item. It's really weird. It's tricky. You have to draw it out, but I've already done so many linked lists that it makes sense. So we're at this iteration, but we want to check if this one is not null. That way we can remove this item, then we can have this one point to the other item. I don't know if this works. Let's see. Didn't work. Yeah, because X is null. I thought I had it. Where's it filling at? My code. Okay. Oh, X. Oh, hold on. I feel like I gotta do this one right. So X is the, oh no, yeah, that's right. X is the previous one. We want the next to point to X, the next, the next. So as long as the next one is not previous, I mean, as long as the next one's not null. Well, we can also, instead of making this confusing, I was gonna say we can store the previous node, but how would I do that?
You don't even think about yesterday.
How would I store the previous node?
Where you got the land.
Alright. Well, then again, also I worked a lot with linked list, doubly linked list, not really singly linked list. So how to Java. How much time do I have? 5 minutes. I don't know how to find a person singly like this. You can't, yeah. If you want to delete the current node, you can do it. Yeah, it's almost like similar to what I did. Node that next. So it's saying, hey, get the next value, store it into the current one. Yeah, well, current node, that next line equals null. Current node. Oh, wait, won't I'm comparing the wrong things. I should be comparing. Oh wait, no, that's right. That's right. I'm comparing the right things. Okay, you know what? I kind of need to draw this out. So I can't really share it here. So I'm just gonna draw it out. It shouldn't be that complicated. We're saying. We're here. And this. We can. What else could we do? What else could we do? I'm trying to think here. Yeah, that makes sense. So we're at this object, and if the next one happens to be our object, then we can set that to null. Then we can have x.next point to x.next point to x.next. Maybe if I did that next. I mean, that looks kind of ridiculous. Let's see. So we're trying to remove this one. X.next.next. I don't know why it's not clicking. I mean, I was thinking about moving on to the other assignment. I mean, the other debugging assignment, but I I want to figure this out too. I mean, I have 19 minutes. So wait. There's 2 removes? Line 40 and 189. Remove object. Oh, so there's 2 different types. Okay. This is testing remove by index. Remove by index. Remove. That's weird. Okay. That's weird. So this one's not even. We should do that. I'll just comment everything out for now. We have another remove up here. Oh, huh. You have a previous node item. That'd probably be useful. Okay. Okay, so we have the previous, if we can get the previous node item. Oh, hold on. This is also an issue too. This should be in the loop. Okay. We're making progress. Expected 4. Because the reason why we need to break and redo n minus. Where is that messing up at? Okay, so something that I did here. So let me make sure I understand this. So we iterate at each, we iterate at each node, and if we happen to be at the index we're looking for, then we want to have x.next. I have a diagram here, but I can't really share it. So x.next, we want it to point to x.next. Okay. And so we do that, and then we need to set the x dot next x dot next dot item equals to null. We want to remove that item or update the stats. So update stats for size, and then we want to break because we are done. And we return the previous node item. Is that what it's supposed to return? Okay. Return the object removed, or null is the index out range. Return the object removed. Return the object removed. Expected B was A. Because it's removing the first one. And that's an issue because that should be out here. If index equals 0, we want start equals or first. So we're saying, hey, this is the first item. For index that are given a 0, we want the first equal to first dot next. And if that's the case, well, first before we even do that, we should do first dot next equals, or first the item equals to null. Set that, we want to subtract one item. Update stats, I mean. We can just do this. And then we just should break and return null. There's a return null if the index is out of range. Return the object removed. Oh, the object removed. So I can just do. Before I even do that, I can do object remove equals to first the item to store it. Then we want first item to be to null, and then we return object remove. Okay. Okay, so that kind of worked. It would have passed this one at least. Next one is doing that again. Right, that's where it's at. We're expecting to be removed. Okay. So for that one, I'm not sure why it's not working. Expected E, but with A. I can do this. I can debug that line. Okay. So you want to step in. Get the variables. Well, I'm kind of curious to see how this list looks. There's only 5 items in this list. A, B, C, D, E. Okay. If index equals 0, which it is, then you remove the first item. Restore that first item, just A. First item equals null. First point to first then next. Take one out, return. So why doesn't it work? Seems like it makes sense to me. Remove expected E. Why would I expect E if it's why would I expect E if it's removing the first one? Okay. For int I. Oh. I see, because it's removing 0. It has values.length. So yeah, this one makes sense. Now we fill the list with test values. Okay, so this one is always removing 0 until it's empty. This one is doing it the inverse way. It's saying, hey, we're gonna start at 5, right? That's the length, 5, and we're gonna go down to 5, 4, 3, 2, 1. That's interesting. So how would you even do that? That's weird. It's so weird. I see. Let me. That is so weird. Okay. So if we're starting at 5 and you want to remove the first one, it's expecting to remove. How would you know that? How much time do I have? 4 minutes. How would you? That's such a weird test. So you remove the last one, but how would it know it's the last one? Like, how would it know it's a tail? How can you start removing a tail? again. Object that remove, and we want to step in. Okay, yeah, that's weird. So we give it an index. What is last is E, first is A. Last is well, in this case, this is assuming we're working with the first item. I mean, working with, with the first, or the head. Index equals 0. I'm not sure. Yeah, I'm not sure. I mean, kind of out of time. But I guess what I would do is, for next time, I would. I'm not sure. It's such an interesting removing it backwards, but they both start at 0. That's what's tripping me up. Like, how is that? How can you move 0 and remove 0 here? You know, and how does it know that that's where I'm tripped up at. But yeah, I mean, I got the other two because I think this one was working clear. So I got set, test set, and test add and get working. I just didn't get the remove. So yeah, there's that. How much time do I have on? I have exactly 1 hour, 60 minutes. Okay, so let me just stop that timer. Quit out that. Okay, so yeah, that's it for this debugging. I did not make it to all these other ones I was thinking I was going to make too, but I tried the best with the linked list. Yeah.